Hi everyone, I'm Alice.
And I'm Lucy.
And this is
Waterfront Wednesdays,
brought to you by
Boston Harbor Now.
Joining me today on Zoom is Lucy Lockwood, a PhD researcher in the School for the Environment at UMass Boston.
Hello, Alice. I'm glad to be here.
Lucy, I'm glad you're here. And for the audience, if you're someone who wants to learn about sea level rise, protected coastlines, and living shorelines, this episode is for you.
We'll be talking about food chains and substrates and how to protect humans from rising sea levels while preserving biodiversity in the Intertidal Zone.
Lucy, let's define some of those terms. You self-identify as an intertidal ecologist. Let's talk about what that means. First, what is an intertidal?
So the intertidal zone is that area of the shoreline between the highest high tides and the lowest low tides.
So it's the kind of places that come to mind when we imagine exploring tide pools, but also it's that vertical section of seawall that's exposed at low tide all the way up to that high water mark.
Exactly. And even in the best of conditions, that can be a challenging region for any creature to live, because twice a day the water comes in and they find themselves underwater, and then twice a day the tide recedes and now they're out of the water. And when they're out in the air, that might be freezing cold in winter, or they may be out in the air in baking hot 90-degree summer sunshine.
It's quite the range. And then what does it mean to study them as an ecologist?
Well, it means that I'm looking at the whole system. So I'm looking at all the different organisms that are living there, not just focused on snails or on crabs or even just on seaweed. I'm looking at all of them and how they interact with each other.
Which is different from a biologist who might just study the kelp or just study the lobster.
Correct. As I look at the system, I want to know who's eating whom, who's competing for space or other resources, how do some organisms maybe even help other organisms by their presence. And I'm also looking at some of the non-living pieces of the habitat. So I'm concerned about things like, what is the water temperature? Are there waves, and how strong are those waves? And what kind of material, what we say is substrate, what kind of material is on the bottom where these things are living?
So what is the substrate or the bottom materials of a typical shoreline?
Well, around New England, there are four basic types of bottom. We have sandy areas, so you think of when you go to the seashore. We have muddy bottoms, so again, think of tide flats, mud flats, where you might go clamming. We have areas that are cobble, so these are the small rocks that you might find in places like Winthrop or Nahant. And then there's hard rocky intertidal areas where we have either rock cliffs or just huge outcroppings of rock, such that you might find in a lot of parts of Cape Ann.
And most of actual Boston Harbor, the inner harbor certainly, it's not natural anymore along the shore.
No, it isn't. We have been altering the Boston Harbor shoreline for hundreds of years, and now most of it is some form of seawall, maybe made from concrete or steel, wood, maybe even the local granite. And we also have areas of the shoreline we call revetments. Those are those big boulders, large rocks, such as you might find along the harbor walk around Columbia Point, where UMass Boston is located.
When you're in a natural version of an intertidal zone, what do you expect to find living there?
Well, it's a very diverse, fascinating area. We have at the kind of the bottom, we have lots of different kinds of seaweed of all sorts of colors and shapes and textures. And living on and among that seaweed are then lots of little organisms, isopods, amphipods, and these are all providing food for larger organisms. They may be snails, crabs, juvenile lobsters, and then are some of our small, what we call forage fish. And these are the small fish that then the larger fish, such as cod or flounder that we want to eat might be feeding on.
So those little things all the way up to the stuff we're eating, all being supported by that intertidal area.
That's the food web. That's the chain of eating that goes on in the intertidal.
And when you started doing this research, you were mostly concerned about what was happening in a rocky intertidal zone that might be heating up because of global warming.
That's right. The Gulf of Maine is heating faster than most ocean areas around the world. And so I was interested in what are going to be the effects on the intertidal zone as the Gulf of Maine continues to warm. And out of that, I then started focusing, thinking, well, what are going to be the effects with sea level rise? And as our oceans rise, and particularly knowing that as our seas rise, we're going to be needing to build more seawalls, more coastline protection.
So your focus now is on creating potentially artificial intertidal areas, but that are supporting a wide range of species. So you've got man-made coastline, but lots of natural diversity.
That's right. What we have found is that even in places where, for example, we were using locally quarried granite, when we build walls, when we build revetments and create these artificial shorelines, they still don't function the same way that natural shorelines would. So one of the things that my research is focused on is understanding what do we need to do in those designs to support the organisms that would normally naturally occur there. So we're looking at things like, how can we provide things like rocks and crevices? How can we provide shading? All of these are important so that organisms don't bake in the midst of summer sun, that they don't dry out when the tide retreats, and that they have places for protection against predators or even protection against strong waves. So the hope of this is, the focus is how we can transform our designs so that we can build not just a straight vertical wall, but walls that have texture, that have different angles, so that they can support the organisms that would normally live there.
Yeah. So in Boston, I think there's a group of people who are part of the environmental movement, the ecological movement, people in the city even, who are really pushing for living shorelines. And when we say that, we often refer to soft sediments like sand or mud or that salt marsh with grasses. But your research is addressing the challenging reality of wave energy. Sometimes you can't build the soft stuff. You've got to build the hard stuff. What do you do then?
Yes, berms and salt marshes are wonderful, and it is something that we should definitely be trying to do. But there are situations where either you don't have the space, because for example, think of some of the places in downtown Boston where there's no room to suddenly put in a salt marsh, or places like out at George's Island, where we're getting considerable erosion that's threatening the historic fort there. But to do a solution out there, you're contending with 10-foot tides, and you're contending with really strong waves that come in when we get our nor'easters. So you're going to have to do some kind of solution that involves some hard substrate there, something that can handle the energy of the waves.
So you want to find that hard edge that also gives you something that's supportive of different kinds of sea life. So you can hold on to the biological diversity and build an engineered solution that feels natural in some way.
Right. What the goal is to design kind of the right kind of substrate, and it may be a mix of materials with different, as I mentioned, things like crevices and shading, so that from an ecological point of view, that we are not just holding back the water or protecting roads or buildings or historic forts, but that we're also creating a diverse, robust, healthy intertidal and subtidal community.
And around the world, people have been trying to figure this out because there's a lot of concrete between the ocean and the humans and the man-made structures on the other side. And if you were to install a bit of concrete the width of a building, it wouldn't matter to the ocean. But it matters when it rings an entire harbor or the length of a highway or harbor after harbor after harbor.
Exactly. Fortunately, there is a lot of research going on worldwide. At present, most of it has been focused in Australia and the Mediterranean and areas like Singapore. And the issue that we have here in New England is that, of course, we have very different marine conditions than in those warmer areas that have much less of a tidal difference, and they have different species. So my research is focused on how can we come up with solutions that work with the organisms that we have living here and the tidal and wave and conditions like having ice in winter that are quite challenging when we're building seawalls.
I feel like people in Boston and the New England area are really proud of the cleanup of Boston Harbor. And they're really excited when we see whales and dolphins and seals and those big species that have come back. But you're helping us bring back more than that.
That's right. We want to support everything from the diverse seaweeds, which I think of as like the wildflowers of the intertidal, of the shoreline, all the way up the food chain.
So you're trying to keep humans safe and keep the ocean healthy.
That's the goal. Thanks for tuning in. I'm Lucy Lockwood.
And I'm Alice Brown.
You can follow me on coastalscience.org.
And you can follow me on Twitter @FairyFairy.
If you like this video, give us a like or leave a comment below.
Or tell your friends, subscribe to this channel.
Wishing you well.
We'll see you on the waterfront.